Hi, my name's Charles and I'm one of the maths teachers from the Maxim workshop. I'm just going to now teach you how to do some math. Hi, I'm going to show you how to calculate the acceleration of a moving object. The first thing we want to do is understand the type of question that you might arise with a particular exam or even a textbook question, and then we can move on to the specific calculation. So the scenario that we're going to give you that will be common within your textbooks and your exams is one with a moving car. So what first of all happens is that you have to understand the variables involved. You might have to deal with a car and the acceleration is denoted by A, double arrows, and as well, the two things that you obviously physically have are the initial velocity that it moves at and the final velocity that it moves at. So when it was here, it would have had an initial velocity, and when it gets here, it will have a final velocity. Okay. So all of this will occur over a given time period. So we'll put this here. Now, an equation that links time, acceleration, initial velocity, and final velocity is basically this one. A equals V, which is the final velocity, subtracting the initial velocity, divided by T, which is the time period it takes for this car to move from its initial velocity to its final velocity. Now, the values that we're looking for here are ones for speed, ones for acceleration, and time. Time occurs in seconds. Acceleration occurs in meters per second squared, and initial and final velocity both have meters per second. Okay, so the first scenario we're going to deal with is one where your initial velocity is less than your final velocity, so i.e. an acceleration. So imagine if this was traveling, the car was traveling at 2 meters per second at the beginning of its motion, and then the car was traveling at 4 meters per second. And the time that it takes for this car to move from 2 meters per second to 4 meters per second is approximately 3 seconds. Okay. Now we would want to calculate the acceleration. So V minus U is basically 4 take away 2. And you have your seconds as 3 seconds. So we have 3 on the bottom. So 4 take away 2 is basically 2, and 3 divided by 3, and that gives you 2/3. And remember, the units of acceleration are meters per second squared, okay? So this is your answer. Now, the second situation is where your initial velocity is bigger than your final velocity, i.e. implying a deceleration. So your car's going slower. So we'll use the same time period as before, but we'll change these particular values for our initial velocity and our final velocity. So our initial velocity, which we're denoting as u, has a value of 5 meters per second. And our final velocity, which we're denoting as v, has a value of 1 meter per second. So you can see that the car was traveling faster here than it was traveling here, which is at the end. So our final velocity, which goes in first, which is v minus u, is going to be 1 minus u, which is 5, divided by 3. Okay, so when we resolve what this is, we have 1 take away 5 minus 4 divided by 3, and we have an improper fraction. So what we're going to do, we're going to change this first of all, and we're going to say 3 goes into 4 once and leaves a remainder of a third. Okay, so 4 thirds will give you 1 third, and 3 thirds, which is actually just equal to 1. So that's negative 1 third, okay? And that gives you meters per second squared. Now, obviously with the fraction, that pretty much would look like this. Negative 1.33 recurring, okay? And in meters per second. But I mean, the only thing you would be concerned with is just changing the improper fraction into a proper fraction, and then obviously writing out the units or so. But this extension is just to see how you would change this into a decimal. So this is sufficient, and that's how you calculate the acceleration of a moving object.